Good afternoon, everyone. Thank you for joining this webinar. So today we are going to present some of the new features available in our new release, Diana 10.10, which is available since mid-December last year, so for more than a month. Everyone with a valid subscription can download and use this latest version. And during this presentation, together with my colleague Milat, Solmaz, Tanvir, and Denise, we will present some of the new development that have been introduced in Diana 10.10. As usual, your microphone will remain muted during this session. If you have any questions, you can type it. There is a chat box in GoToWebinar. So you can type the questions. From time to time, I will try to have a look. And if the questions is relevant for the whole audience, we will try to answer it on the fly, or we will get back to you per email after the session. This webinar will be recorded, and by the end of this week, it will be available on our YouTube channel. So if you want to share it within your organization, there's no problem. There will be a recorded session. So let's start and have a quick look at the content of this webinar. So first, I will give you a short introduction to Diana, something relatively quick. Then I will present our new corporate identity, and then we will move towards the new modeling features, the enhancement in terms of material models and analysis and results, and also in terms of tutorial and documentation through the rest of the presentation. Having said that, let's start with a short introduction about our company. So Diana is a short form of displacement analyzer and is a general finite element program which is dedicated to all type of civil engineering structure. It can be a bridge, it can be infrastructure, but also to geotechnical and petroleum engineering applications. Our aim is to provide a range of efficient engineering solutions for the daily or specific type of engineering project problems that you may face by increasing the accuracy of the final results. And in that way, our clients could optimize the cost of their project, because at the end of the day, money is one of the key factors. Our core values are presented on these slides, can be summarized in 3 words: reliable, collaborative, and solution-oriented. So what we mean by that is based on the trusted relation we develop with our clients and partners, we try to mature dynamic and innovative ideas, and then we do our best to deliver a state-of-the-art solution and quality service in a world-class product. I would say this is our target every day when we start developing Diana. Let's go through some of the main applications that are listed on these slides, and we start with geotechnical and tunneling. We have a very good integrated solutions for all type of geotechnical and tunneling applications. So you can use integrated environment of Diana for any types of tunneling and underground structures. For ground freezing, we have the so-called 3 phases analysis. For real soil structure interaction, we can, so basically if you have some sort of interaction between the underground and the surrounding soil or rock, you can model it with the concept of nonlinear interface behaviors. We have a solution for copper groundwater flow stress analysis, and many more, such embankment on soft soil and consolidation, or slope stability. Next to that, we have a very comprehensive solution associated to reinforced concrete and early age behavior of the concrete cracking. That's mainly when the model and the casted concrete goes through the process of hydration. For any types of concrete, box girders or composite structure, we have a solution. For dam structure, it's also very important because of the process of casting, curing, hydration, and impounding. So again, Diana can be considered as a good and proper solution. We have also a good coverage for design check, including the reinforcement based on the Eurocode, mobile load and design load generator, and the cross-section design check. You can use it in conjunction with your bridge application or your general structural analysis applications. We have different solutions in order to give you a good estimation about nonlinear response of the model without entering into the nonlinear detail parameter input and setup iteration, like the sequential analysis. Temperature and stress coupling let you analyze how the concrete goes through aging. Cooling pipe is also another powerful feature that we offer in both 2D and 3D in order to control the hydration process. Crack initiation and propagation in concrete is one of the powerful features in Diana, and also fire effect, how the fire could affect the durability of your structure. Among other applications, we can refer to masonry and historical construction. In Diana, we offer different solutions at meso or macro levels, so you can use Diana to model the interaction between the individual bricks and the mortar joints, so to this level of details. For dams and dikes, Diana offers the solution. It covers all the aspects of construction for all types of dam structures. You can consider the fluid structure interaction, dynamic effect, and also induced damage to the structure. Fire analysis is another area that, based on its importance these days, has become one of the main topics for structural checks. And again, Diana can be considered as one of the most reliable solutions. For earthquake analysis, you can use Diana for general dynamic or seismic. So again, we have a complete solution. Another advanced type of application where Diana is very well known is the field of oil and gas and nuclear structures. Based on the type of complexity, you can simulate 3D geomechanical depletion or borehole stability, for instance. For nuclear structures, you can analyze concrete containments or underground waste storage. So this is it for the short introduction and about Diana. Most of you are probably already familiar with the program. I can see from the list of attendees that most of you, the name is familiar. So let's now move to basically some of the new aspects available in 10.10. And before talking about the new features, let me talk about the new corporate identity. If you are familiar with our social network, or if you have visited our website, you probably noticed that since the last quarter of 2024, we have a new logo with a new color available on our website, on our social network. So this is our new corporate identity. It's more modern, more up-to-date, I would say, and it gives a fresh and dynamic look to the company. So this is our new logo. You probably also notice on our website our new corporate identity, also since the last quarter of 2024. Our website has been updated and revised, so you can see that it looks more modern and more, let's say, up-to-date with what you expect in the 21st century. Also, the look and feel of Diana, the graphical interface, has been updated with our new logo. So, for instance, when you start Diana, you can see in the background our logo, but also on top. And when you look at, for instance, information about your license, you can see the new Diana logo available everywhere. So basically, the new corporate identity is basically available at every stage, every part of the program. So now let's move to the new available features, and we start with the modeling part. So in previous Diana version, you had the possibility to basically define a frequency dependent factor diagram, but it was not possible to do that via the graphical interface. It was possible to do that via a DAT file using common syntax. So now in Diana 10.10, it's now possible to define the frequency dependent factor for complex load by means of frequency load diagram for both the real and complex part, or by frequency phase diagram. So that's what you can see in these two screenshots. So what was possible via a DAT file up to Diana 10.9 is now also possible via the graphical interface. We have a specific graphical window to input this diagram. Another new feature is, or let's say partly new because it was already available in 10.9, is the pre-stress load. So in Diana, it was already available, and in 10.10, basically, a couple of extensions have been made. So now it's possible to do that with reinforcement, embedded reinforcement in bonded situation, and also with Anchor. So this is more an extension of an existing feature. So basically to make it more complete. In Diana 10.10, the default background color of the modeling window has been, let's say, updated. So in the previous version, it was kind of a blue gradient, and now it's white. You can change this background color by going to the preference menu. From the main menu, you go to Edit Preferences, Appearance, and you can change the top and bottom background color. But by default, it's now white instead of the blue gradient, which is also more convenient if you make a screenshot and you want to use the screenshot. Then we have also non-orthogonal support. In previous Diana versions, so up to 10.9, it was not possible to define support in nodes that were not common to non-perpendicular edge. This is now possible in 10.10, so you can define support on this non-perpendicular edges. And in addition, you can prescribe deformation in this direction. So this is also something that we have improved in Diana 10.10. So this is it for my part. I'm going to pass the presentation to my colleague Milad, who is going to talk about the composed element. So Milad, if you want to unmute yourself.
Yeah. Hello, everybody. Thank you, Jean-Claude. If you can go to the next slide, please. Here I'll be talking about a new feature for composed elements. Previously, only those continuum elements which were completely located inside the range of a composed elements contributed to the forces and moments. But in the case of coarse meshes, this could lead to fluctuating force moment diagrams. In Diana 10.10, now there is the new option for considering also the partially cut elements. You can see the difference in these left and right images. So now every element that even has a small portion located inside the range of a composed element will be considered in the calculations. Next page, please. This option can be activated in the composed element geometry definition down in the box. The default sample point number is chosen as 5. This number is used to calculate the number of continuum, the volume of the continuum element that is partially inside the composed element range. The user can play with this number. If you choose a smaller number, the accuracy will be compromised. If you go for high number, you won't get a lot of accuracy gain, but computational cost will increase. So this is a kind of a trade-off that has been chosen as the default. Next page, please. And here we have an example with a coarse and distorted mesh, especially in the midspan of this beam. You can see that in the previous versions of Diana, the results not only fluctuate a lot, but also there are some regions with no values at all. This is because there are no elements in those regions that are completely in the composed element range. But with the new feature, if you enable it, you will see a big improvement in the result as in the right side contour plot. That's it for me. Thanks, Jean-Claude.
Solmaz, if you want to unmute yourself.
Thank you, Jean-Claude. Hello, everyone, and good day to you all. Here I will explain one of the new implementation in Diana 10.10 for the material model section. The title is Tendon Relaxation in the Bonded Slip Reinforcement. The tendon relaxation refers to the gradual reduction in the pre-stressing force in tendons over time due to the viscoelastic behavior of the material. This phenomenon is significant in the reinforced concrete structure, particularly for the long-term simulation. In Diana 10.10, the viscoelastic behavior is implemented by incorporating two different chain types. The one is Kelvin chain and the second one is a Maxwell chain. This material model describes the time-dependent behavior of the material. Next slide, please. As you can see on the screen, a simple beam with a one tendon in the middle is modeled in Diana 10.10 to show the effect of the viscoelastic behavior on the strain result during the time span. And thank you. I will give the panel to my colleague, Tanvir.
Tanvir, if you could unmute yourself, please. Tanvir, you can proceed.
Okay. You hear me now?
Yeah, we can.
Okay. Yeah, great. Thank you, Solmaz, and hello, everybody. So it is another. It is another material model that is developed newly in 10.10. It is about plasticity with bar buckling. This is a model that is available in embedded reinforcement, bond slip reinforcement, or also on truss elements. So in compression, the buckling behavior is captured as a material behavior here. And in terms of material parameters, it is similar to Monegato-Pinto model. And but it has some extra parameters which basically tells the slenderness ratio of the reinforcement. And if we look at the tension envelope, it is typical yielding, then an yield plateau, and then some hardening. But the compression behavior is much different. It shows the sharp degradation of strength after buckling. That is basically monotonic tension and compression behavior, or the envelope behavior. But a lot of care is taken when it is cyclically loaded, and it is composed. Each cycle is composed actually of a number of Monegato-Pinto type curve. So in different situations in compression and tension, we have different source and target point, and special considerations like from unloading, from compressive side, it is not as steep as we saw the unloading behavior from the tension side. So that's roughly the new material I talked about. The next slide, please. Yeah, this is an analysis feature. In the past, we had we didn't have compressibility effect in the situation of transient nonlinear analysis, and now we made the extension, so fluid compressibility can also be considered in transient nonlinear analysis. In many situations, the effect of compressibility may not be prominent. It becomes prominent if the input signal is higher than the cutoff frequency. With cutoff frequency, I mean the first fundamental frequency of the fluid domain, and it is roughly the fluid velocity of sound in the fluid divided by the 4 times the height of the dam. And in this situation, we have tried to give an example where we have shaken, say, the dam in this case it is not really a dam but a dam-like body. We are just shaking in the horizontal direction, but with a frequency that is higher than the cutoff frequency. And then we compared what happens if fluid compressibility is considered and if it is not considered. And we see a sharp difference. In case of incompressible assumption, the effect remains very close to the in the fluid part, very close to the dam. And on the other hand, in case of compressible fluid, we see it is spreading towards the far field, and the elastic wave is quite visible. And another new thing is, like in the past when we considered compressibility, it is the fluid pressure results were only available in the fluid structure interface part. But now this result is presented as a nodal result, which is pressured off in the fluid domain. So we can see the whole effect over the fluid domain. Next slide, please. It is a new result item, element forces in the interface. In the past, we had element forces in the interface, but that was available only in the global direction. But for certain applications, like a typical situation, like the interaction between the interface forces between the dam and the foundation, there it is particularly useful to get the element forces in the local direction. Of course, we have local tractions, normal and shear tractions available, but then one needs to multiply them by the element area to get the force. That can be quite cumbersome. So now we have made available this element force in local direction. So if we compare this result with traction results, the pattern will be the same, but of course the values are different. So now we can see the forces. So that's all about my part. I think then my colleague Denise will continue. Thank you.
Thank you, Tanvir, and good afternoon to everyone. This one is a new item for results. So Indiana, generally element output results can have 3 different locations, and this has been there in the later versions. So we can give the location of nodes, which is the default location, and we can also choose element integration points and averaged results in element center point. The new thing about the ANA 1010 is that now it's displayed, so we can easily see what we chose. The difference was that in previous Diana versions, we only had the information displayed about the result location when different locations of the same result item were asked in a given output. So if you changed the default, but you only had one result type, then Diana will not display in the tree which location we were talking about. And also Diana didn't display the location in the legend, so in the title at the bottom, at the top, where we see the load and the name of the result. So the new thing about Diana 1010 is that whenever you change the default, which is node, so whenever you change the default of the element result location, Diana will give the information about that location, both in the tree, and it will always give the location in the legend of the result display in the title. Next one, please. This one is so about the Diana AI, the interface. So we can now change the color of a selection of shapes. This was not possible before. So now you can first select the shapes and then go to the property panel and select the shape color and pick one color. And it will reflect here in the geometry browser when you have the colors of each shape. That's all for me, so I pass to Solmaz again.
Thank you, Denise. So I will continue with new enhancement in the results and post-processing section in Diana 10.10. The title is Scale Annotation in Legends. As you can see on the screen, in the Properties menu in Diana 10.10, Diana offers a Scale Annotation option. This feature helps a user to understand what portion of a structure is affected by each contour limit. In a previous version, in these percentage are calculated based on the number of elements in each contour limit. But now in Diana 10.10, these percentage are calculated based on the area for the 2D and the volume for the 3D problem. And also for the phase analysis, the only active part of the model in each phase is considered in the percentage calculation. Next slide, please. The next topic is interactive definition of the probing curve. In the previous version, for definition of the probe curve, user needed to input the node coordinate of the probe curve manually to the table. But in the Diana 10.10, we introduced a new snapping tools for the definition of the probe curve. Could you please play the video? Thank you. As you can see on the screen, by activating the probing curve, the new snapping tools is appeared on the upper toolbar. By clicking on the green tick mark sign, you can select a point or coordinate on the model. And after that, by activating the red cross sign, you can eliminate the nodes that you don't require them anymore. Also, you can drag the point on the model by the mouse cursor to your desired location. And after that, you can easily have the probe curve in Diana 10.10. Thank you. I will pass the panel to my colleague, Jean-Claude.
Thank you very much, everyone. So special thanks to Milad, Solmaz, Tanvir, and Denise who assisted me today for this presentation. As you can see, we have done quite some work to improve Diana, and we are still working on it because in 2025 we are planning one big release by the end of this year. So there will be again a lot of new functionality and new features, which basically will fit with the demand of the market and the end user. Another point that I'd like to mention is please keep an eye on our website because there's a lot of events coming, and there will be new trainings and also a couple of live webinar where we do live demos. So I invite you to keep an eye on our website or to register to our newsletter to be informed about all the events that we are planning in the coming weeks. So I would like to thank you all for attending this release webinar. As I mentioned in introduction, this webinar will be published on our YouTube channel. So by the end of this week, you will be able to watch it on the YouTube channel. And if you want to share it with your colleague or within your organization, feel free to do so. And again, I'd like to thank my colleague and all the team of Diana who has been working hard for this Diana 10.10 version. And we hope to see you in one of our next events, whether a course or one of our free webinars, which are planned in the coming weeks. Thank you all and have a good day or good morning, depending where you are located in the world. Thank you. Bye.